one term called a monomial. Mono stands for one. And then next lesson, you'll be doing adding, subtracting where there might be multiple terms in the denominator. But the idea is going to be the same no matter what. So when we're adding fractions or subtracting fractions, we need to have a common denominator. That's the key idea and what makes it different from multiplying and dividing. So let's just go ahead straight into the first check your understanding. I am going to do B, and then you can try, or sorry, I'll do A. And then if you want to try B on your own and check the answer down below, you can. Okay, so let's just rewrite it here so I have more space. I have 2x over 7 plus 5 over 3x. And before I start doing anything, I do want to write my non-permissible values. So for this one, x cannot be 0 because x is in the denominator there. Okay, so let's focus on the two denominators. I need to make these the same. So I need to figure out what the lowest common multiple is and make both of the denominators into that. So let's focus on the numbers first. 3 and 7. So the lowest common multiple is going to be 21. So I need to multiply the numerator and denominator of the first one by 3 to make 21. And I'll do 7 for the other one. Okay, now the second fraction also has an x. So that means the first fraction must also need an x in the denominator. So we need to multiply by 3x, actually. Okay, I think that's it. So let's go ahead and do that. So 3x times 2x will be 6x squared. And I'll have 21x in the denominator. And then for the second fraction, in the numerator, 5 times 7 is 35. And in the denominator, 3x times 7 is 21x. Always, you should end up with the same terms in both denominators. Okay, so now I can simply add the numerators together. And since they're not like terms, I cannot actually add those numbers together. They're just going to stay separate because the first one has an x squared and the second one doesn't. And I'll have 21x in the denominator. And that's my final answer, along with that non-permissible value. Okay, and there we go. We can see it's the same there. Okay, let's try a slightly more challenging question where maybe we have more than one term in the numerator. Let's try check your understanding number 2. So I'm going to rewrite it. So again, I'll do A and then you try B on your own if you would like to. Okay, so x plus 5 over 8x and x minus 7 over 6x squared. So again, remember for adding, subtracting, we need to make these terms the same in the denominators. So focusing on the numbers first, the lowest common multiple between 6 and 8, the smallest thing they both divide evenly into is 24. So if I multiply this one by 4, 6 times 4 would be 24, and I'll multiply the first fraction by 3, because 8 times 3 is 24. Okay, now let's look at the x terms. The second fraction has x squared, and the first fraction just has x. So to make those match, I'm going to multiply this first fraction by x. Okay, let's go ahead and write what I've got here now. Now, we have to be careful. If there's more than one term, we have to multiply this 3x into both terms. So I'll have 3x squared plus 15x all over 3x times 8x would be 24x squared. And again here, if I have more than one term, I have to make sure to multiply the 4 into both. So I'll have 4x minus 28 all over 24x squared. Perfect. So now the denominators match. One thing I forgot to do is write my non-permissible values. For this one, x cannot be 0 because that would make the denominator 0. Okay. Now finally, we're going to add these together. So I would have, and we're going to add any like terms. The other terms have to stay separate because they're not like, they don't have any like terms. Okay, 15 plus 4 is 19. And then the 28 has to stay separate, 24x squared. There we go. And from before, x cannot be 0. That's it. So the only difference here between check your understanding number 1 and 2 was that because the numerators had more than one term, we had to make sure to multiply that 3x and that 4 into both terms. Okay, let's try a slightly harder example now where we have three rational expressions to add or subtract. So I'm going to go ahead to this one here. Again, I'm going to do A, and then you guys can try B on your own and check your answer down below if you like. So you guys are going to try this one. I'm going to do this one. So I'll have 5 over 2 minus 3 over 4a squared. I'm going to leave a little bit of space. Plus 2 over 3a. So I need to make all three of these denominators the same. Before I do that, though, let's write any non-permissible values. So the only variable I have in the denominator here is a. So my non-permissible value is going to be a cannot be 0. Okay, so the lowest common, let's focus on the numbers. Lowest common multiple between 2, 4, and 3 is 12. So I need to multiply by something that's going to make 12. So for the first fraction, that would be 6. For the second fraction, that would be 3. And for the third fraction, that would be 4. Let's focus on the variables now. The middle one has a squared. So I need to have at least a squared in every single denominator. So the first one, I'll need to put an a squared there. And the middle one, we don't need to add anything because I already have a squared in the denominator. But for the other one, I have just one a, so I need to add an a to what I'm multiplying by. Okay, so let's write what I've got now. Okay, so first one, 6a squared times 5 would be 30a squared. And the denominator, we're going to have 12a squared. Here we'll have 9 over 12a squared. And here we'll have 8a over 12a squared. And finally, we can just put all of those together because now all the denominators are the exact same. 30a squared minus 9 plus 8a all over 12a squared, and we had the non-permissible value, a cannot be 0. Now, when you're matching with the answer key, this is not wrong what I've written here, but just conventionally, in the numerator and denominator, we typically write the highest powers of a first, and then lower and lower and lower from there. So we're going to switch the order just to match the answer key. Again, it's not wrong to write it in any order, just by convention, though. We write the highest powers of a first. So this is our final answer there. Okay, and that's the end of the lesson.